And we've got Tim Curwick. Want to send that right, Tim?
Yes.
All right. PowerShell MVP, automation consultant, author. He's going to talk to us about error handling and logging in PowerShell.
Awesome. All right. Am I correct in assuming you have the usual mix of PowerShell skill levels and job descriptions in the room?
Yes.
All right. This is a good talk for that because this definitely two topics that can help anybody start to up their PowerShell game: error handling and logging. There's the button. I need to share my screen. Here's my information, although I don't tend to not blog a lot recently or Twitter very much. I just got a like today on a Twitter I sent about a year ago, which may have been my last one. But you can contact me if you want to. You can email me anytime with questions. Always happy to talk PowerShell, also on Slack from time to time. I was one of many co-authors. The PowerShell Conference book came out last year, and we have the PowerShell Conference book Volume 2 coming out this fall. A lot of good stuff in there. Brings us to PowerShell handling and logging. One of my personal maxims: any script that requires human interaction is a broken script. We write scripts so that we don't have to do anything, so we want them to just go off and do their own thing so that we don't have to. But if we are turning these things loose in the wild to run on their own or in the middle of the night, they need to be able to handle whatever comes up, and we need to know what they did. That's error handling and logging. If we are writing tools that we are handing off to Tier 1 help desk to do things with, we need to often make the tools, because the help desk isn't always the brightest bunch, and so we need to make the tools smarter than the people sometimes. So it needs to be able to handle what comes up, and when things are at a point where they're going to need to be handed off to us, as they have to escalate, we need to know what happened and why. So we need to handle that logging. So these two topics are very closely intertwined, and they often tend to be iterative. You do start your first script with some basic logging just to see what happens. We don't know what's going to happen when we try to do certain things in a new strange environment and throw all of our whole user base against it. So we might do logging to find out what kind of errors might happen that we need to worry about. We don't have the time or resources to invest in anticipating every possibility. So we do some logging to find out what the important things are, and we start so we can start doing some error handling. Some of the error handling is just logging that there was an error. So then we understand the error better, and so then we can go back and fix our system so that we don't get the errors, or we can modify our code so it knows what to do in those situations. So these two things very often happen hand in hand. The first easiest way to handle errors is to simply don't make mistakes. Now that sounds facetious, and it is to a certain extent, but there is actually a point to that. Let's go start looking at some code. I will be posting this demo code wherever you ask me to, or I can just point you to the link where we've got it posted on our Minnesota group. A lot of the code you can run and test. It does also come with a companion script that you can run first that sets up that mocks a bunch of things to make some of this demonstration work. Some of the code isn't for running; it won't do anything. It's just for sample purposes. But you will have access to all of it. I'm going to cover a lot of stuff. Don't worry about picking up all of it while we're going. Just start to get some of the concepts, get the code, play around with it, start working on using at least little bits of it in your next scripts, and keep going from there. There is, again, I'm going to talk about a lot. So if I go over time, or people have families and lives and better things to do, feel free to cut me off or to leave the room. I tend to keep talking PowerShell until everybody else leaves. Then I know it's time to go home. All right. So one simple thing to do in a lot of cases is to just not have errors. So for example, I might be getting a string value, and then everywhere server 1 shows up in these references, I want to change it to server 2. Simple replace works fine, but the problem is that sometimes what I'm getting back turns out to be a null. It's not a string. I try to run a replace method on it, and it throws an error. Quick side note, thing that can help considerably. Human beings are bizarre things. When you hear an alarm go off, an announcement being made, humans will do one of two things. We'll either completely ignore it, or we will immediately head for the door or for the fire hose or whatever we think we need to do. We ignore it or we take action. What we don't do is actually listen to the announcement that they're making. We're really bad at that. And the same thing happens with error messages. When we're doing PowerShell and red pops up on the screen, we do one of two things. We ignore it or we go try to find and fix the problem we think exists. What we don't do is actually read the message. I guarantee not one of you actually reads the message as often as you think you do. It's amazing how many times people post in Slack or the forums or whatever, I'm having this problem, I'm trying to do this, I run this, and I get this error, what do I do about it? And it states very clearly in plain text in the error exactly what happened and why and how to fix it. So just the simple step of, in whatever platform you're using to do your PowerShell, change your error messages so they show up as green instead of red, and you'll actually read your messages more often and actually be better and quicker at handling this sort of thing. If you're colorblind, well, you're out of luck, and there's all sorts of things that are more challenging, and I'm glad I'm not you. Sorry. Meanwhile, with our error with the servers, so now at any time I'm going to do a string method, I just cast the thing that's supposed to be a string as a string, grab that in parentheses to make that cast happen, take the results, and then it will always be a string, and I can run replace on it. So now even if it comes back as null, I do not get an error, and it goes on. My result is going to be, an empty string instead of a null, but most of the time that's exactly what I want anyway. It works perfectly fine. There's one very rare circumstance in PowerShell 5 and older where this doesn't actually work. There's actually multiple kinds of nulls, and they screwed one of them up. But 99% of the time, this totally, completely avoids that issue. I never have to worry about it. Another example, in this scenario, I need to be able to convert email addresses to distinguished names for users. I need to be able to do it quickly and easily. So first thing I'm going to do in my script is I'm going to go ahead and get all my users from AD at once, and then I am just going to create a hash table, and I'm just going to populate the hash table pointing email addresses to distinguished names. And this is an awesome way to reference such things quickly. Problem is, if I'm getting everything in Active Directory, I will definitely be getting objects back that don't have an email address defined, and that's going to throw an error because I'm trying to use a null in this hash table reference, which doesn't work. But PowerShell gives us multiple ways to do a lot of things, including multiple different ways we can reference hash tables and work with hash tables, and they have pros and cons in different circumstances. So in this circumstance, instead of using this syntax, I just, nope, sorry, that's from a different lecture. So what I'm doing in this case is just using a simple if statement around it, so that if this object has mail, then I can go ahead and stick it in the hash table. If it doesn't have a mail address, then I don't need it in the hash table, and I can just ignore it and go on, because it's only the mail addresses that I'm trying to convert. And so by doing this, I get no error building my hash table, so I don't have any errors I need to handle, and then it's real quick and easy to do the cross-reference and convert my emails to distinguished names. Yeah, the different syntax for hash tables is useful for other errors, but we won't cover that today. Another related related thing is just handling problems before they become quote-unquote errors. So in this example, we're looping through a bunch of employee IDs for each one of them. We're querying our custom internal HR API to get information about the user, and then we're going to do stuff to the user. When we run that, in our case, we get an error because the problem is that one of the employee IDs we had in our list isn't in the HR system, so we got a null back for that. And then when we try to use that down here, then that throws an error. We couldn't even handle that within our do stuff function because the PowerShell is going to get cranky if you try to use a null with the name parameter. So for handling that, we also have another problem here, and that problem is that we have this loop that we're running over and over again. If on a particular pass through the loop, this throws a non-terminating error, user will be unchanged, and but will keep going. And so I will do the loop twice for the exact same user. So that's about a problem that we would like to avoid. So what we're going to do is on each loop, first thing I'm going to do is I'm going to set user to null. Anytime I'm using something that might be defined in a earlier in the script or in a higher scope, I'm going to set it to null right there so that I know that this is a fresh, empty thing in the local scope. And then we go ahead and do our query. No matter what happens there, if that doesn't work, user is still null. And then we just do a quick conditional. If user is populated with something, then we can go ahead and do stuff to the user. And if it's not, then we write to the log. And so now we can grab that and run that. Well, shoot, I was running through some of this earlier, so that didn't have it was supposed to fail again. It was supposed to fail because we haven't yet defined write log. So let's define write log. I have just two variations on write log that I use constantly, pretty much every single script. Just copy the functions from one script to the next as I'm going. A few years back, I did go through a phase where I would regularly add more bells and whistles, make them fancier and able to handle more stuff and do more stuff. But ultimately decided that was a bad idea because then I had a versioning problem because I was embedding the functions within scripts so that I had no external dependencies. And I had different functionality in different scripts, and depending on where I was copying from and what I was doing, and what I wanted to do, copying different chunks and scripts, there were some issues there. Plus, I found that the vast majority of the bells and whistles weren't really that useful anyway. So I finally settled on just one version of the function and one variation of it that I now use for everything. And I will share both of those. When I first show them to you, it's going to be simplified versions of the two, just to make it a little clearer how they work, and then later in the session, we'll do slightly more complex versions of them. Then first, at the top of every script, going to be setting up where we're logging. And that because we're doing this logging in a function like this, if we decide we want to do something different with it, in these examples, the code that I'm sharing, it just logs to a local file, or to a network share, wherever you want to log, but to a text file. But if you decide that you want to start doing all of your logging to a database, or sending out to Datadog, or doing whatever you want to do, then you just create a new function, copy and paste it into all of your scripts where it needs to be. All of your write log commands work as before, and everything is nice and simple. But most of the time, just writing to a file is all we need and what we want to do. So we're going to define a log folder. And then I always define a file-based string. And this I'm going to use everywhere where things might need to be linked together. So this is going to be the name of the script, or at least part of the name of the script. This is going to be the name of the log file. This is going to be part of the name of any config files, any output files. If there's a scheduled task kicking off this script, that's going to have that same name, so that all of these things are really easy to find and link together and understand what goes with what. Then I'm always going to stick a date string in there. Year, month, day, so that it can sort in in date order. And then sometimes also adding the time on there, hours and minutes. Then you'll do that or not do that for different scripts as appropriate. You'll be surprised to find out that it's mostly actually going to be the exact opposite of what you think it's going to be. If you've got a script that's on a scheduled task running every 5 minutes, you actually don't want hours and minutes on there because you don't want 400 new logs every single day. Going through those one by one, trying to find stuff is a royal pain, so you don't want to do that. So in that case, you're just going to use the date so that all of today's stuff all goes into a single file that's easy to find. If you are, on the other hand, if you've got a script that just runs once a day, you'll actually probably want the time in there. And that gives you a few things. One, just looking at the logs in the log file, you can easily see that one of them ran at an unexpected time of day. It's out of place. The date that goes here is essentially the start time of the script. This is up the top of the script, so this is when it started. And then just in Windows Explorer, you've got right there the start time, and then last modified date is going to be the end time. You get the start time and the end time of the script right there without even having to open the logs and look at them or go look at histories anywhere else or anything. So that is very useful. And then we just put it all together. Where we're going to put it, file-based.datestring.log. If we're going to have multiple types of logs, maybe there's going to be an error log, maybe there's an action log that is specifically designed to be used to help roll stuff back. For all of those, you just add another dot, then another description for what's going in there. If you got config files, you just add a dot config or whatever, and make everything very similar and easy to find and easy to keep together and easy to correlate. And what order you put things in depends on what's convenient for how you want to sort or find things. So then we come down to our simple function, write log. Top of the function, we put commandlet binding. As a general rule, put that on top of all your functions. It's magic. We'll show what the specific types of magic it is later, but even when you don't need it for specific magic, it is just magic in general. It does stuff like change how PowerShell does variable handling for a function, which can make it more efficient and perform better. Not by a lot, depending on what you're doing. It's probably not measurable, but if you are doing things where the speeds of your functions matter, then all of the overhead of your functions matter, it can make a difference. Just taking a single parameter, just the text that we want to log. I am breaking best practices here in that I'm not taking the log path as input. I'm assuming that it's defined elsewhere and just referencing that. And I'm doing that because much of the time I'm going to have write log in my script a lot. Sometimes almost in between every single line of code, there's going to be a write log. That makes it hard enough to see and understand what's going on with the script. And by removing that dash path $log file from every single line, makes it a little less cluttered and a little easier to read the script and see what's going on. And so then I just I prepend the date time to the front of the text, so I don't have to do that manually, and then just write it to a log file. UTF-8, because it's a global world. If you're in PowerShell 6, you don't have to do that. That's the default. And then I write it to the screen, just for in production, generally my scripts are going to be off running somewhere where no one can see them. But while I'm testing and working on them, I want to be able to see those things popping up, so I'm going to write it to the screen. Not going to use write host. Write host is bad, especially on older versions of PowerShell. We don't want to just dump to the output screen because maybe this function is being used within a script that's going to have output. And we don't want to mix these messages with the actual output of the script. So we write it to the verbose screen or verbose stream where it can't do any harm. Send it to the screen, makes it a nice pretty color, a nice cyan. And then we use the verbose switch here because that overrides the verbose preference. It always writes it to the screen. So if you are writing something for end users to use in at a command prompt, you might modify that so it's not always writing to the screen. But for most of what I do, that's perfectly fine and just what I need. So if we run that and define that, And then, for example, we just run it. It does the nice verbose to the screen, and that exact thing, starting with the date, gets written to the file. Here's one trick I've learned over the years. Anytime I'm embedding a value in what I'm writing to the log, I wrap that in square brackets so that it's very clear in the log that that isn't hard text, that is a value. And that helps distinguish between what's hard-coded and what's not, and it also makes it more obvious when there's missing information. If it just said employee ID not found, then it doesn't seem to convey as much information as very clearly employee ID square bracket nothing square bracket not found. That it is a null value. An exception to that is if you do need to extract that data from your logs. So if, for example, you need to correlate things, or if you run it and you did something and now you need to undo it, you need to go through your logs and get all the information about these things, and to run another script to undo it, then adding those square brackets can make it a bigger pain in the ass to parse those logs and get that data out. But for the most part, this is a good idea. The only variation on that script I'll use is when, instead of writing to a text file, I want to write to a CSV file. There are from time to time situations where it can be very useful to be able to sort data. Maybe I'm combining logs from multiple servers that I want to be able to see what's going on in different ways. Maybe I've got a script that only runs on one server at a time, but could be on any of several different servers, and they all write to the same log file on a network share. I want to be able to break things down and see what's happening where. And so I'll use the CSV file. And so again, we just bring in the text, and then we build a PS custom object, because that's what you need to do to export to CSV. We take the date and we convert it to string manually to both for readability when you're looking at it just in Notepad, then so we can better control the accuracy of what's going in there, and still makes it something that Excel understands real easily. In this case, I'm adding the server name. There could sometimes be other additional columns you might want for correlation across the different things you're combining, and then we just have the text and a column, and then we export it to CSV, UTF-8 again, and away it goes. And then for writing to string, this goofy thing here is just a trick to quickly and easily extract the values out of an object and string them together, put them on the screen, and make it easy for humans to read. One thing to keep in mind when using CSVs is most of the time our scripts are running on servers, and you don't have Excel on the server, so when you open it, you're opening it in Notepad, and that's fine, because Notepad does not lock files when it opens them. So the script can be running, you can open the log file when it's halfway through to see what it's doing so far, and that won't interfere with ongoing logs. But if you are connected remotely to the file share or server where this is being logged to, and you open that log file in Excel, Excel does lock the file, and then all of your logging from that point forward will fail as long as you have that open in Excel. Not a major thing, just something I learned the hard way and passing on. So let's look at an example of doing some logging. So here's a simple script where we're basically still doing what we did in our example above, but now we're going to do a bunch of logging. You'll also see that I have in here my standard internal comments, which I do a lot of. And you'll also see me doing a lot of things like this, where I have internal comments saying, we're going to query the HR API, and then I log. I'm querying the HR API. Then I've got a command, query HR API. And you will see people telling you that for internal comments, you shouldn't do stuff like this. If it's clear what the command is doing, you don't need to do a comment. But they're wrong. There's nothing wrong with this, and this is good. If once you've been working with a particular editor for a significant length of time with a particular set of color theme, your brain gets used to that and works really well with it. That's the last reason why I'm the last person on the planet still using ISE instead of going to Visual Studio Code. And you quickly get so that, as long as you're not colorblind, you can quickly scan through a script and look at just the green and see just the comments. And so if you have good comments all the way through, that explains exactly what's happening all the way through. Or you can look through and look at just the text for all your logs, or you can just go through and look at all the commands. So there's nothing wrong with having that level of redundancy. You don't want to get too carried away and make it too hard to read. You know, there's a balance to everything. So for our logging, I'm going to start at the beginning, saying I'm starting, and at the end, I'm going to say I'm ending. This is also learned the hard way. That it's especially important to have the one at the end. When you look at the log, there's only a certain number of employees in there as processed. Is that because it thought that's all it had to do, or is it because there was a problem? Whereas if at the end we're saying this is the end, then it's very clear that as far as the script knew, that's all it was supposed to do. And then inside, and you don't always have to do this, do logging this detailed, but it's also not that hard to go through a somewhat finished script and just add a bunch of these real quick, where every time you touch a variable, you log it. Every time you try to do something that might go wrong, you log that you're going to try to do it, and when it's finished, you log what you did, what you got back. So in each loop, we log what employee ID we're working on, and we log we're going to query HR, and then we log the results, either the object we got back or some piece of the object that clearly shows what it is that we got. Then we go, if we did get a user, we log that we're going to do stuff to it, and then we log we successfully did stuff to it. Then if we didn't get a user, then we log that the user wasn't found in HR. And then when we're done, we're done. So we run that, boom, and we just went through and start processing. 113, querying the API, got the user, did stuff to the user, successful. Employee 182, query HR, got nothing, not found, and processing. All right. Well, any questions on those functions before we start to get really fancy?
Looking good. Good.
All right. So let's start doing some error handling. The workhorse of error handling are the try, catch, finally blocks. So you take your main code and you stick it in try, and it just goes through and it does that stuff. If everything works, and that's what happens. If at any point within the try block it throws an error, it skips the rest of the try block and jumps down and runs the catch block. And then after it's completely done with the try and or catch, then it runs anything in the finally block. Try block is required. You must have either a catch or a finally block, or both. You don't see the finally block a lot, but it is very useful in certain circumstances. We'll talk more about that later. So let's start taking a look. There are some very simple things you can do with it. Like you can use it as the ultimate silently continue, where you just take whatever you're doing, stick it in the try block, and then you've got a catch block that does nothing. So you try it, if it doesn't work, you go to the catch block, you do nothing, then you move on with your script. So we just run that, and the way it goes, if there's an error, it just disappears into the void. Simple example of where that's useful. It's like if we've got a path to something that doesn't exist and we run get item on that, we get an error. Now, in this particular case, we can just use error action silently continue on that command, and that suppresses the error, and we're fine. But sometimes you end up with a path that is an empty string. And in that case, silently continue does not suppress the error, because the problem with error action silently continue is, one, the code inside the function or commandlet needs to be written to handle that properly. And so sometimes it gets ignored, sometimes it doesn't do it well, but also it only affects what happens inside the function. It doesn't help if the error happens before the function even starts. As in this case, the error happens because PowerShell didn't like it when you tried to give it a null for path. It didn't know what to do with that, so it threw the error before the commandlet even started to run. So that still throws the error. So in this case, we can just take the whole thing, wrap it in a try block with an empty catch block, and now it's a perfect silently continue. Another example, if I spin up some run spaces, I'm doing some multi-threading, and I open up my run space. If then later in my script, for some reason, I don't have the clearest logic or whatever, I try to open the run space again, then it throws an error. But I want to make sure that if this isn't open, that it does get open, but I don't necessarily want the bulk and overhead of checking its state before trying to open it. I can just wrap it in a try catch. Try to open it. If it opens, great. If it throws an error, just move on. Let's look at our first simple try catch. We're just going to loop through the numbers 0 through 2. We're going to log which one we're working on, and then we're going to try to divide 1 by whatever came in. If there's an error, we're going to skip everything else in the try block and jump down to the catch block. And then if it's successful, then it'll continue logging the try block and skip the catch block, and then go on to the next loop. Because we're doing the try catch inside of this loop, then it will go on we are handling the error, and it'll go on to the next loop and keep doing all of them. If we were to put the for each inside the try block, then as soon as it hit the first error, then it would jump to the catch block, and we would be out of the loop, and we would not continue. So if we run that, for 0, we try the division, jump down to the catch block, logged error, went to 1, that one we got a result and success. For 2, we got a result and success. And the catch block never runs if you don't get an error. Questions about that? Cool. Let's get complicated. So let's start taking a closer look at errors, see what we've got, what useful information in there, and what's going on. Every time you get an error, PowerShell adds it to the error array. Does it upside down so that the error 0 is always the most recent one that you got. I do highly recommend, if you're going to go start looking at an error, that you assign it to a variable. Because otherwise you're looking at error 0 and you're trying different things, and sooner or later you mistype something and you cause another error. Well, now the error that you want to look at is now error 1, because your new error is error 0. And so then you got to try to redo what you did, get to error 1, then you accidentally make the same error again. Now it's error 2, and you're chasing it all the way down the stack. So I highly recommend assigning it to a variable so that it stays put and it's easier to look at. Now, when we first look at it, it looks like that's not too useful. It's just the error message that we got before. But actually, errors are very complex objects with lots of information. It's just that way back in PowerShell 1.0, they thought it would be useful to force it to come out like this, that this would be very helpful to us. So that's what comes out. Most of the time when something isn't behaving and showing you all of the information, we just pipe it to format list. But in this case, that still doesn't work because they were trying to be really helpful. A lot of times just throw in an asterisk. I want all of the properties. still doesn't work. They're being really too helpful. But if we add a dash force in there, then we actually get the full object. And so that's what we always need to do, is just pipe it to FL star dash force. And of course, in our scripts, we never use aliases, but when you're at the command line looking at errors, then that's perfectly fine. So inside of an error, a lot of it is super complicated stuff that nobody that isn't, a deep C# developer cares about. And where's my, oh great, the battery's dying on my mouse. This is going to be fun. We've got the exception inside it, which we will get to. There's a target object, which there isn't always something in there, but this can often be a very useful thing, can be what you were trying to work with. And I'll show some examples of that later. Script stack trace can be helpful. If you're have the error inside a function in a module that was called by another function in the module that was called by a function in your main script that was called by another function that was called by your main script. The script stack trace will detail where in each of these scripts you were and what called what. Now you got to the spot where you're having the errors. That can be sometimes useful. The big thing inside here is the exception. The error record itself is a PowerShell construct. Below the sheets, down in .NET, it doesn't think of errors, it thinks of exceptions. What happened was an exception, and that's what it handed back to PowerShell. PowerShell took that and wrapped it in an error record. So we can take a look at the exception inside the record. And if you just do it like that, you don't get much useful. It's the same thing you have to do. Pipe it to format list star force, and that gives us the full information. What information you get for an exception is going to vary based on the type of exception. Each of them is, there are hundreds of thousands of different types of exceptions you can get. And a lot of it, again, is stuff you won't understand or care about. Only the people who wrote Windows would care about it. But there's often useful information in there. And again, different errors are different, so go look into new ones and see what you can do might be able to do something with, and I'll show some examples of that too. One thing you won't see when you're looking at it like this is what kind of error it is. Annoyingly, that doesn't show up as a property, but there's different types of exceptions. So that so what type it is embedded in what type it is. So we just run get type on the exception, and specifically look at the full name of the type of the exception, and we can see this one is a system.management.automation.runtime exception. Sometimes they're more generic than others. Now, as things happen down in the .NET layer, just like in PowerShell, there's things calling things, calling things, calling things, and sometimes an exception happens down deep, and as that exception is handed back up through the stack, sometimes different layers will take that exception and wrap it in another exception and send it up the line. So there can be an inner exception. So we can look at the exception's inner exception and see in this case that it's much simpler than the outer exception was, but there is another layer there. It is possible for inner exceptions to have inner exceptions, but that doesn't happen very often. And we can look at the inner exceptions type, the full name of that, and that was a system.divide by zero exception. So that is more useful in a couple ways. One, it explains a little bit better what's happening, and it also gives us a better way to handle it, which we'll get to. So let's look at another example. Let's go ahead and try to access a web page that doesn't exist. Let's stick the error in a variable so we can see it. Let's do the FL star.force and take a look. And this time, the target object is populated, and it's a very useful one. This is the actual HTTP web request object that was used to try to talk to the website. So if we take a look at that object, we can see it is a very big, full object with lots of information. When you run invoke REST method, it has a lot of possible parameters, most of which we ignore most of the time and just use the default values. If you're troubleshooting trying to connect to an API or whatever, and it's failing, it can be very useful to come and look in here and see what these things are set to. Read the documentation on the API or whatever you're trying to connect to, see what kind of things it's complaining about or might have problems with, and you can see where there might be mismatches between its requirements and what invoke REST method is doing by default, and realize you do need to use some of those parameters you hadn't thought about before, and to set something to go the way it needs to go. Or sometimes you'll find that a particular setting needs to be set that invoke REST method doesn't have a parameter for, at which point you need to abandon invoke REST method and start working directly with .NET objects instead. But going in and looking at this target object within the error can be very helpful for troubleshooting. We look at the exception for this error. If you memorize the previous one that popped up, you can see that this exception does have several different fields from the divide by zero error. One of the things we have here is the target site. And this is the web response object that represents what actually came back from the server. If we take a look at this exception, this is a web exception. If we take a look at that response, we can see all the details of the response that came back, and we can dig into some of those. The status code was not found. I know from working with these things in the past that status code is actually an enumeration. So if we convert that enumeration to an integer, we get 404. And so we can build our error handling so that it responds to different web error codes differently, depending, so a not found is handled differently from an unauthorized error. We can take a look at the headers. It's not a pure hash table object, so it doesn't spit out the values nicely, but we can see the keys here, and then we can dig into each of those and see what's in there. And sometimes there's useful information there, like if you're talking directly with the APIs for SharePoint, embedded within the headers is actually performance information about what was happening on the servers at Microsoft. And so if there are really slow responses, that is very useful for proving to Microsoft that the problem really was on their end because their own server said it was on their end, rather than the problem being with your network or with the internet in between. Now, if you're actually looking at these things in your script, you don't want to use error 0 because of the nature of how errors and exceptions happen, and because things can trigger other things. Sometimes in the moment, error 0 isn't actually the one that you need to be looking at. But when you're in a catch block, the pipeline variable $_ always represents the exact error that caused you to go to this catch block. So that's how you reference the error while you're there. So we can just write log, get our exception message, and boom, there it is, attempt to divide by 0. That's in the log. We know exactly what happened. So sometimes your error handling is that simple. Just try catch, write to the log what happened, so that you can, something goes wrong, you can go figure out what it was, so that you know how to go fix your system or tweak your script. Sometimes you want to log more details. And when I do this, this is pretty much the details that I always log. So first I will log a message that I wrote. I was trying to do this and I got an error. Might give a little more details about what I was trying to do, the file path or whatever. And then I'm going to log the exception message. That is the main message of the error. And then I'm going to log the type of the exception, because that can often tell me a lot on what type it is. And then if there's an inner exception, I want to know what the inner exception's message is. I generally don't bother logging the type of the inner exception, because isn't often an inner exception, and when there is, knowing the type isn't necessarily helpful. And if there isn't an inner exception, then trying to run get type on it fails because it's a null object, and you have to do handling for that, and it's annoying. So in general, this is the most useful information to always log: the message, the type, and the inner exception message. So we run that, and boom, we get all of that right to our log. Makes it a little easier to figure out what happened and what to do about it. And because these are the most common things to log, I put those actually in my write log function. So let's take a look at the full write log function. That is exactly what I use in most of my scripts. So now as parameters, we're taking the text, and we're also taking an error record. And so, as before, we prepend the date to the error message, and we log it, and then we write it to the screen. And then we check to see if the error record is, in fact, an error record that came in. So we know how we can handle it, and it's not going to throw any errors. If the user, for some reason, sends something else weird, we just ignore it. Not useful anyway. But if this is an error record that was passed in, we can go through and recurse write log to write the error message, the type, and the inner exception message. If we run that, and then if we throw our error, then this time in write log, we just add -record $_. And so when we run that, all that information is always written to the log. And then the same thing if we're doing a CSV. This time for our object, we're adding additional columns where error type and inner error might be. They're empty strings by default. But if we did get an error record, then we go ahead and populate those columns with that information. Now put everything to the log. If you do have multiple scripts or multiple runs of scripts, possibly in different servers, writing to the same CSV file, it's extremely important to make sure that your logging functions exactly match. Because if what you're trying to write to a CSV is different from one export to the next, you will lose data because it's only going to write columns that were in the very first thing that went. So anything else that, if first you write something without an error column, then you write something with an error column, you won't get the error column, it'll be missing. But most of the time, you're just going to have a single script writing to a single file, so that's not an issue. Right. Now, the reason that looking at the full name was important, A, because it helps you know what it is, B, it helps you research it, but C, we can also make our error handling specific. Instead of just catching any old error, we can tell PowerShell to just catch very specific errors. And all other errors, just treat like normal errors. We're only going to do the special handling for these special ones. And we do that by, after the catch keyword, we just put the type of exception in square brackets. And so now only those types will be caught. So we've got this function that just takes any number, tries to give us the inverse. If it's a divide by 0, we return infinity. So now the inverse of 2 is 0.5, the inverse of 0 is infinity, and the inverse of potato is an error, because that's a different type of error than a divide by 0 exception. We can have more than one catch block. We put the more specific types of errors up at the top, because the first catch block that matches is what's going to be run. So in this case, if it's a divide by 0 exception, we've got this catch block. For any exceptions that are not divided by 0, then they get caught by the other one. So now with that, the inverse of 2 is 0.5, inverse of 0 is infinity, and the inverse of potato is the smartass response. Now we can have opportunity to really take advantage of that more easily in some cases. Sometimes it's a pain in the ass because sometimes the developers that wrote whatever it is that you're leveraging decided to use an extremely generic error type that doesn't significantly distinguish it from similar errors. But other times you do get very specific, like divide by 0, which is helpful. There are also multiple ways you can reference different exceptions. Every type of object in .NET, in PowerShell, is based on a different type of object. They're not totally completely out of whole cloth. It's starting from this base. We're going to customize it. And so everything that is one thing is also more generic things. You know, like in real life, you know, my car, you know, my Corolla is also a car. It's also a passenger vehicle. It's also a vehicle, all the way and up the line. Though in .NET, everything is based on something all the way up to the very top. There is something called system.object, and everything is descended from system.object. In order to see what an object comes from, we look at its base type. So we can take an exception, get its type, and then look at the base type of that type, or the base type of the base type, or the base type of the base type of the base type. And we always want to look at the full name to be useful. So if we look back a little bit at this error, if we just look at that error, it's just a system management automation.runtime exception. Its base type is system.systemException, whose base type is system.exception, just to be confusing, whose base time is system.object. And that's the end of it. Doesn't go up from there. Everything is based on system.object. We can also look at the inner exception. The inner exceptions is system.divide by zero exception. Its base type is system.arithmetic exception, and its base type is system.systemException, which takes us to system.exception, takes us to system.object. So in all, within this one error record, we have 4 potentially interesting and useful exception types. We have the runtime exception, the system exception, divide by zero exception, and the arithmetic exception. And each of these things, you know, so for all, we can catch not just an exceptions type, but any of its base types will catch it, and any of the inner exceptions types or nested inner exception types and any of their base types are things that we can catch a particular error with. So we can do something like this, where we've increased the complexity of our function a little bit. We're not only going to return the reverse, the inverse, we're also going to try to return 10 times the input, and then we've got multiple catch blocks. So we've got our divide by zero exception, and then we've got arithmetic exception, which is broader than this. So any arithmetic exceptions that are not divided by zero will be caught by this, and then any exceptions that are not in the above 2 will be caught by the bottom block. So if we define that, and then if we so big inverse of 2, we get 0.5 and 20. Big inverse of 0, we get infinity, and we just got one response because we got an error in the first thing, which immediately takes us out of the try block. It skips everything else. We caught the divide by zero exception. We returned infinity, and we were done. The next one, we're taking the max value of decimal, and we're running that, and the inverse comes back as 0, appropriately rounds to 0, but then we try to multiply by 10, and that's too big. We were already at max, so it's not a divide by 0, but it is arithmetic, so it returns also infinity. And of course, big inverse of potato is still smartass response. Any questions on that? That starts to get that interesting and useful, and not useful for everything, but every once in a while. Like especially if you're handling web responses and you're handling the different types of possible errors differently. That can be very handy. All right, let's move on. Yeah, looking at the time, there's no way I'm going to fit everything in by 6:30. Do I have a hard stop at 6:30, or can I keep going for anybody that hangs out?
Yeah, I think we got to do a hard stop because we've got a couple of things to mention, and then we got to get out of here. They close the library. We meet in the library, and they close at 8, so we got to.
Okay, that's fine. I will fit in everything I can, and of course I'll post the code, and I'll also give you a link to the YouTube video for the St. Louis group. They let me keep talking. All right, so we can get complex with the nesting of these and how we do different things. let me start by closing this all up. So we've got our outside basic try catch. We go into the try and we do thing one. If that fails, we skip everything else. We jump down to its catch block and we log that it failed and we're done. But if that was successful, we go on and we go into another try block, within which we go into another try block where we do thing two prep. And this was something that we're going to try to do to get ready for thing two. But if it fails, we go into the catch block where we do nothing. It was something good to try. If it failed, oh well, I don't mind. So we use the catch block to just ignore that error and move on. So then we do thing 2A, and if that works, then we're successful and we're done with the script. If that fails, we go into the next catch block, within which I've got another try catch. So within that try, we try to do thing 2B. And if that works, we log it successful, we're done with the script. But if that fails, we go into its catch block and we log that neither of them worked. So we can start to get really complex with these things when we have really complex error handling needs. Sometimes you want to intentionally throw an error. Just for fun or because it simplifies the logic of your script. And the way you do that is with the keyword throw. So if we run that, that just throws an extremely generic error. We can't get more specific. We can give it a particular error message. We just give it a string, and that pops up now as the error message. And that particular error message was a lot funnier when I gave this talk up in Duluth and had to drive up there to get to it. We can throw it a particular type of exception, like the divide by zero exception. We can just say throw one of those, and it will. If we do it like this, where we just take an empty hash table and cast it as that, we get the default value. So we get the default error message attempted to divide by zero. Or if we want, we can go with the divide by zero exception, but give it a custom error message. We just cast the error message as that exception. It sticks in the right place. And we've got a particular type of exception, so we can handle it if we want, or it looks appropriate to whoever is looking at this, but we've got a custom error message. All right, now we're getting into some error action examples, and here's where we start to get a little funky. So now we're going to try to get this item that doesn't exist, and if that fails, we go into our catch block, and then we run it, and it threw an error up on the screen and did not write the log. What the heck happened? Well, the problem there is PowerShell has this useful but complex and sometimes annoying thing, the concept of a non-terminating error. Other languages don't have this. .NET doesn't do this natively. In .NET, most languages, you get an exception, you have to handle that exception, and if you don't, everything breaks and your application just stops. PowerShell, part of its purpose is to be a command shell for admins to do stuff at the command line or doing ad hoc scripts or anything else like that. If you're writing a script that's just going to go look for a bunch of files and then delete them, but some of them aren't there and that throws an error message, well, you don't want to care. You don't want that to break your script. We didn't want it there anyway. Just throw some red on the screen to let me know what happened and kept going. And so PowerShell came up with the concept of a non-terminating error. So some types of errors just throw red on the screen and keep going. Other types are more serious errors. They're called terminating errors, and these are normal errors. And these will break the script and or need to be handled. And it's those types of errors that the try-catch block catches. In this particular example, that was a non-terminating error, so the try block did not catch it. It just used the behavior of error action preference. That's what determines how non-terminating errors act. By default, that's set to continue, means throw red on the screen and keep going. If we set it to stop, that effectively turns all non-terminating errors in terminating errors. So now our try-catch blocks can work as expected. So we can run that, and now it's properly caught and logs instead of throwing an error. So let's turn it back to normal for some more examples. What was I talking about here? run through all this today. Here's where some of the magic happens. With a normal script, by default, if you don't define it that way, your function doesn't respect the error action switch. So if we run this against a display that doesn't exist, it throws an error. And if we put in error action silently continue, it still throws an error because we didn't write the script to handle it. But we have magic at our disposal. We can make it handle that with for a lot of basic functions with no work whatsoever, doing nothing but adding in commandlet binding. And that commandlet binding not only makes error action and a bunch of other switches available for use by that function, it also automatically implements a lot of the functionality for you, so you don't have to. Taking that exact same script and adding commandlet binding, same function, and run that. Now, normally we get an error, but we throw error action in there, and now we don't get an error. It just magically works. I like magic. Now, the part of the challenge with that is it doesn't work exactly the way you think it works. You might think that when it runs, the function gets an error and returns an error, and then PowerShell grabs that and responds to it accordingly. But it doesn't happen that way. What happens is PowerShell basically changes error action preference within the function. And when that happens, that can change how your script works, make it happen in ways you didn't think it would. So in this version of the example, if you didn't have, if you weren't using error action, and you got to this throw statement, that throw statement would cause it to exit out of the function. But if we have error action silently continue set up, then that throw statement is ignored and it continues on, and it with the rest of the function, and it returns something, even though we didn't intend it to. So we had an error with silently continue. It ignores the error and continues with the function when you hadn't thought it would. This also points out that just in general, as soon as you turn on commandlet binding, which overall is a good thing, and you probably should always do so anyway, but that means that anytime an end user modifies error action preference, that can modify how your function behaves. You just have to be aware of that possibility when writing your code, or don't worry about it, because most of the time it's not an issue. But if strange behavior happens, then just have in the back of your mind somewhere to remember that that could be an issue that you might want to look at more closely. Rethrowing errors. Sometimes you catch an error and decide you don't want it and throw it back out for the next thing to handle, or to do things at multiple different levels in different catch blocks. So in this one, we go into a nested try block, and we try to import a module, and if that fails, then we go into a catch block and we log it, and then but I don't want to continue with the rest of the script, so I do throw $_ to rethrow the same error that brought us in there, which jumps us all the way down to the master catch block at the bottom of the script, where I'm sending an email message to my support team to tell them that I got an error. And so all through this whole script, I've got the one big master try catch, and then within it, I've got for each section, I've got a try catch, and if it fails, and this is something that script can't continue without, it does its local thing, but then rethrows it to get to the outside. Unhandled errors. Ideally, when doing something like this, you want to handle all of the errors, and so you've written it so that you think you're handling all of the errors, but sometimes you're not. So we're just down at the very bottom in my final catch. I know ideally, I think that I wrote it in such a way so that all errors are handled above, and the only way I can get down to this final catch block is if I intentionally did a throw to rethrow to get down here. And so I want to know if I got here without doing that. Fortunately, there is a property built into every exception called was thrown from throw statement. So I can very clearly ask, am I here on purpose? If not, I screwed up in my code somewhere. I want to log that I have an unhandled error, do all my usual logging, get error record. On top of that, I want to add the script stack trace because something funky is going on. I want to know exactly where it happened so that I can go back and fix my code. And then I send my email message. Finally block. Finally blocks are awesome for cleanup. The error action preference, for if I'm writing a script that's just, one-time use in PowerShell, a scheduled task kicks it off, runs my script, and then it goes away. Then it doesn't matter what I do with error action preference. But if I'm writing something that I might be testing on my machine, or I might be giving to end users to use, or to my help desk to use, then if I'm modifying error action preference for my needs, then that gets screwed up for their needs. So I'm going to, at the beginning, I'm going to capture the current error action preference, set it to stop, and then I'm going to have all of my code wrapped in a try block, and then I'll have a finally where I change the error action preference back to what they need it to be. And there's many other examples of things that you want a finally block for. A lot of times there are things, most of the time in PowerShell, we don't clean up after ourselves. But sometimes there are things you really need to clean up. If you're creating remote sessions to exchange online, there's a limit to the number of those that you can have, and so you don't want to lock yourself out by running this script too many times and not cleaning up after yourself. You want to remove the module and close that session every time. If you're a lot of different places, or sometimes you need to delete things and clean them up or clear out memory because you're going to be using more of it. You want to do those things. Now, the wonderful thing about finally, you might think, well, what's the point? Why do we, this just runs after try catch, why don't we just put code after try catch? Well, the makes it super useful is the finally block always runs. If PowerShell still exists, the finally block always runs, no matter what happens. It's like if you're running your script and you get an error, it's going to run down and do the catch block, and then it's always going to go down and do the finally block no matter what. If you hit Control-C to stop your script, it's always going to go down and do and run the finally block. If you've got a return statement up in try, normally you hit this return and this goes back and you're done. But if you have a finally block, it's always going to go down and run the finally block before it exits out of the session, so you can clean up after yourself after you've already set the stuff back. If PowerShell doesn't exist, it can't do that. So if you hit the red X on PowerShell, it can't do finally. If it's running as a scheduled task and something kills the task, it can't run finally. But as long as PowerShell still exists, finally always runs. So it's very, very useful for cleanup. I demo to prove that. And it's about time. You'll see trap out there, which was a PowerShell 1.0 thing, pretty much replaced by try catch and V2, but still sometimes useful, but rarely. But we don't really have much time to get into that. And then I was just going to, we're pretty much done. Then I was just going to show you, a big, huge example of and this is, and you'll see this when I post the code. This is excerpted from an actual script I wrote for a client last year. The actual script was several thousand lines long, so this is a muchly simplified version, but still starts to show you the complexity of what you can do when you need to within a script to do complex error handling and logging. So with like 3 seconds to go, any questions?
Pretty good. Yeah, really great.
Thank you.
Thank you, Tim. Really appreciate it. It's really great.
Thank you. I just wish someone would want to hear something else. I've given this talk in 6 different places around the world now, and it's a good talk and very useful, but I really want to talk about something else once in a while. So have me back sometime.
Absolutely. We'd love to have you back.
I got a quick, maybe this is a quick question. Have you ever tried logging instead of to a text file or whatever, but trying to log to a production enterprise logging product like Log Analytics in Azure or Elk, something like that, without using the agents that you can install to kind of, gather the text and then insert it in, but directly out of PowerShell?
Yeah, I mean, not those specifically, but I actually very recently wrote functions for logging directly to Datadog, and I wrote a function for writing directly to Kafka. Then I've got a function I've used for years for running SQL queries against SQL Server, and I've recently enhanced it so it'll work against ODBC connections, so I can talk to Impala and other kinds of databases. But yeah, and so if you have a nice standard write log function where you've used write log consistently through your scripts and through all of your scripts, then if you do want to start logging to something else, you just modify the function and you don't have to worry about the rest of your code, and just paste it into your scripts where you need it. Or in some circumstances, like my current big client, I'm writing for a particular team where they're writing a lot of custom functions for them, so I'm already creating a bunch of modules for them. So in that case, I've taken the write log functions and put them into modules. They don't have to be in the individual scripts. And so then, and we're now exploring tweaking it so that instead of all of their scripts writing to a local log, they'll all write directly to a database, and I won't have to make any code changes at all. We'll just change the function in the module.
Okay. For Kafka, what method did you use to write to that?
Just talking to the REST API.
Okay, gotcha. Okay.
Well, let me think that through. No, I lied. I do have. I took the Confluence.Kafka .NET objects and I embedded them in my module. So there's no local dependencies. They can just install the module and it just works. And it's all .NET objects, and they're a little annoying to work with, but it's one of those things where you can't just create a producer. You have to create a config object from which you create a builder, from which you create a producer. So the software developers like doing things the hard way.
Okay, thank you.
Anything else?
That's it. Great.
All right.
Thank you.
Thank you much. Hope it was helpful. Let me know where you want me to post the code or send it, and I'll also send you a link you can distribute. But then it's a little bit later here, so I'm going to go home before my wife gets pissed. So thank you much, everybody.
All right. Thank you, Tim.
Bye.
Thank you.